All right, go take your homework out if you would, please. Turn your textbooks to page 149. Page 149. We're going to begin by looking at the two word problems that you had for homework last night. Word problems 24 and 25. And then we'll take a look at the rest of the homework that was on page 153. So page 149. And there's the two word problems. That's where we're going to begin. Good and good. We're going to start with those. Page 149 in your textbooks. Bueno. Muy bueno. All right, starting on 24 and 25. It says on number 24, the length of a rectangle is 2 feet less than twice the width. The perimeter is no more than 46 feet, and the dimensions are integers. Is that a good thing or a bad thing, Maddie? Bad thing that the dimensions are integers? Oh, maybe? What's an integer, Maddie? It's a nice, easy whole number. So it's a good thing, right? So in other words, if you get something fractional or weird like that, you'd be like, nah, not counting that number. So we know we got to get a nice, easy number here. No fractions, no decimals. It's going to be happy. We're the largest possible dimensions of the rectangle. Obviously, two unknowns here, Noah. The two unknowns were the length and width. I'm just going to do L and W. And which one did you choose to be X?
The width.
The width, and you represented the length.
X negative 2.
I'm sorry?
X minus 2.
X minus 2. 2 feet less than twice the width.
And
2x minus 2. Now that is going to change some things then, isn't it? And we know that the perimeter of any rectangle will be equal to what, Brecken? Just in general, to find the perimeter or the distance around a rectangle, we would have to have all the sides, which would be 2 lengths and 2 widths, correct? So we could say in general perimeter is 2L plus 2W, for instance, or perhaps 2 times L plus W, or L plus W plus L plus W. There's a lot of ways to represent it, but this is the way we learned in junior high. So when they tell us the perimeter is going to be no more than 46 feet, that means the perimeter class is going to be less than or equal to 46 feet. So this value, the 2L plus 2W, has to be less than or equal to 46 feet. But of course, in for the L class, we will substitute 2x negative 2. Well, we could probably do that in our head. 2 times 2x minus 2 class.
4x minus 4.
Plus 2 times W, well, W is just x, so class 2x has to be less than or equal to 46 feet. Of course, we could combine the 4x and 2x here, class. 6x. At the same time, we could go ahead and move the 4 to the other side as a positive 4 to get 6x less than or equal to 50. And again, this is why it's important that it said integers, Maddie, because 6 doesn't go evenly into 50. How many times does 6 go into 50, class?
8.
8, a little more than 8. Am I going to round up to 9 or down to 8 here?
Down.
Down. Even if it were 8.99, we'd have to round down to 8. Does that make sense? Because it's a less than. So we'll say x is less than or equal to 8. So the width has to be less than or equal to, class, 8 feet. And therefore, since we have to stay less than or equal to 8 on the width, the length is going to have to stay less than or equal to 14 feet. So the dimensions, the maximum dimensions would be 8 feet by 14 feet. How many had that answer on number 24? Questions? Noah, you forgot to have 2x minus 2. It sounds like that would throw things off. Maddie? I'm sorry? You got it. I'm sorry. I did not see your hand. All right? You moved one finger and I didn't see it. All right, Brecken? Forgot the you had 2x and x. Okay, you had 2 feet less than the twice. All right, number 25. Shannon's first 4 test scores in grammar were 81, 79, 82, and 76, each out of a possible 100. What must her 5th test score be for her final average to be a B, between 80 and 90? Can she score high enough to get an A? If not, what's the highest grade she can achieve? So we're trying to find an average. How do I find averages, Maddie? Add them all, divide by how many there are. Now, so far, I've got 4 scores, right? I've got 81, 79, 82, 76, if my memory serves me right. Let me fact check myself. Yes. And then there's going to be one more test, which we don't know what she's going to get, so we'll call that. But we know if we add them all together and divide by 5, we want to see, can she earn, or what does she have to get right here to end up with a B, right? A B would be 80 to 90, right? So to end with a B, she needs to have at least an 80. At least an 80 means, and there's the inequality we were shooting for here. Add them all together, we want greater than or equal to 80. Did we get this by any chance for our inequality? No. All right, I'm going to throw this thought out there. If I were to put this over 1, that would turn this whole ugly thing into a? Well, it turns the 80 into over 1 into a fraction, but it turns the whole thing into a proportion of sorts, in which we could cross multiply. I could multiply here the 5 in the 80 class to get 400. And I could multiply 1 times all of this mess, and of course I get all of this mess again, right? Let's go ahead and add, though, there at your seats, these first 4 values together, if you didn't already. If you already did, go ahead and just call it out. 318? Got that from a couple of people, so we'll say 318 plus x. And then obviously here, class, to finish solving, we'd simply need 2. And we subtract the 318, we find that her 5th test score needs to be greater than or equal to 82. Okay, so in other words, the answer to the first question, she needs at least an 82. An 82 gets her a B. Well, the second question is, could she get an A? I don't know. How would we figure out what she could get? What's the best score she could get? A 100, right? So now let's just see, well, what if, forget all of this mess, what if she got a 100 right here? Well, then her total would be 418 divided by 5. Again, this is the best she could possibly do. Yeah, 83.6, 84. Can she make an A? Not with those scores, she can't. But she can make a B. She can make as high as a, mid-range B. I'd say 84 is pretty much mid-range there, right? But no, she's definitely not making an A. But at least an 82. 82 is manageable. She did it once before. Okay, that would match her highest grade, but, she's done it. I don't see her getting the 100, but you never know. Stranger things have happened. Questions on number 25, how to work with averages. Of course, as you two know, since you took computer apps last year, I believe it was, right, you could always just put it into an Excel spreadsheet, just keep punching in numbers too, and let the computer do all the work. But anyway, I digress. Turn over to page 153. Page 153, let's see how we did on some inequalities. 5 through 23, the odd. 5 through 23, the odd. Check your answers on these. Number 5, you should have gotten x is greater than -4. Or you might have had -4 is less than x. Number 7, you should have had that x is less than 5/3, or perhaps you had 5/3 is greater than x. Number 9, you should have had x is less than or equal to 3, or you might have had 3 is greater than or equal to x. Number 11, a compound inequality should have had -2 is less than x is less than 2. Number 13, another compound inequality. This time you had to divide by that negative and flip stuff around. Should have had -10/3 or -3 1/3 is less than x is less than or equal to 4. Number 15 should have had -1 is less than or equal to x is less than or equal to 2. Number 17, having this absolute value inequality, should have started by dividing by 2 to get the absolute value by itself. Would have gotten 4 put in between less than the positive negative 4. To get negative 5 is less than x is less than 3. Number 19, this time you're going to just start with a positive negative 12, but you're going to go outside ranges. To get x is less than negative 14 fifths, or x is less than negative 2 and 4 fifths, or x is greater than 2 as your second range. Number 21, you've got an isolated absolute value less than a negative. It can't even be negative, much less be less than negative, which would be even more negative than negative, so definitely no solution on number 21. Hopefully you caught that. And number 23, when you got the absolute value by itself, you end up with that greater than there, set outside ranges, and go x is less than negative 2, or x is greater than 1 as your two separate ranges. Did anyone get all 9 correct? All right, 8 for 9, you just missed 1. Ooh, okay, Bracken, good. 7 for 9, just missed 2. Okay, Maddie, questions on the ones we missed? Let's take 5, 6, or 5, 7, and 9. Any questions on 5, 7, or 9? Going once on 5, 7, or 9? Twice on 5, 7, or 9? Gone on 5, 7, or 9. Good, that means we've got the basic gist of the inequalities down. Compound inequalities, 11, 13, 15. 11, 13, 15. Going once on 11, 13, 15. Twice on 11. Okay, that means all of our issues came on the absolute value inequalities. Is that correct? Reckon the one you missed was absolute value?
The one I missed was number 9, but I only forgot to put the
or equal to. Okay, so as far as the process, you're perfect on the process. You got it down, just forgetful because you're human. Okay, Maddie, which two did you miss? Were they both absolute value? 13 and 17. Okay, 13, did you figure out what your problem was? Because you didn't raise your hand for a question. You had 4 is greater than or equal to x is greater than negative 10 thirds and just had to flip it around. Okay, does that make sense how to do that? You're good to go. Okay, just need to remember to. Okay, and then you said 17 had a question. I assume you divided by 2 first, right? To get absolute value x positive 1 is less than 4. Did you start with a number line? Actually drawing in the negative 4, the positive 4, the x plus 1 in between, or did you go outside? So did you then write negative 4 is less than x plus 1 is less than 4, the compound inequality? Okay, yeah, so when it's a single set, it just progressively gets bigger, right? Everything inside the range just gets progressively bigger. So negative 4 is the littlest. X plus 1 is all of these points in between, which is bigger than this one, but they're still smaller than 4, which is your biggest. So yeah, the less than progression all the way through, okay? And that was your only mistake, all right? It helped that 19 and 23 were both greater thans, and that the only other less than ended up being a no solution. So yeah, when you're setting up the compound inequality, just let them progressively get bigger, so less thans all the way across. All right, Noah, let me come to you. Which ones did we miss?
9, 13, and 21.
9, 13, 21. Did you figure out what you did on 9 yet? Okay, you said 19 was the other? And then 21?
13.
13, okay. Did you figure out what happened on 13?
Yes.
Okay, and then 21, you tried to solve it. You put your positive, negative 8. Yeah, so that's just where you've got to pay attention. Once it's isolated, a negative over there is either no solution, or what about greater than a negative, class? What if you've got absolute value greater than negative something? Is that no solution also? No, it's got to be what? All real numbers. Because remember, absolute value is always bigger than a negative, isn't it? Because absolute value always spits out a positive. Positives are always greater than negatives. So yeah, absolute value greater than a negative should give you all real numbers. Questions on that? All right, let's take a look at a couple word problems here on this page now, page 153, number 29. Take just a moment to set that up and solve. Page 153, number 29. Okay, well, go and do both 29 and 30. So they're on page 153. word problems 29 and 30. Work both of those. Number 29, what did you write for your inequality first of all, Noah?
5n plus 3 is greater than 38.
Very good. And when you saw what you got?
7. Or n is greater than 7.
And it's greater than 7. Good. We wouldn't want to just leave the number 7, would we? That's not our answer. Our answer is everything greater than 7. Good. Number 30, what did you write for your inequality on this one, Brecken? Uh-oh.
And I subtracted the 120 from it. Oh, I didn't do 120. I don't know what I was doing.
All right, Maddie, help him. What should we have written for our inequality? There we go. We've got a certain number of hours he needs to work. We don't know what that is, but if we multiply that by 7, we'll get how much money he makes working that job, correct? Plus, he gets $120 just flat for another job. And he needs this amount of money to be at least $270, right? Greater than or equal to 270. Now, as far as how we actually do the work, you're right. We will start by subtracting the 120 to get 7x is greater than or equal to 150. And then we will probably do what you, I assume, did next, and that was divide by 7. Now, when we do, 7 goes into 15 class, 2 with 1 left over, 7 goes into 10, 1, and we end up with 21 and 3/7. Okay, it's a weird mixed number, but assuming you don't work fractional parts of hours, especially something fractional like 3/7, how do I round, up or down? Up. Even though normally this would round down, we're rounding up, so we're going to say he needs to work at least 22 hours if he wants to make that certain amount of money. Does that make sense? How many had this inequality? Did you guys have it? You did not either. Does it make sense now how to set that up? He's got two jobs. One makes $120, the other makes $7 an hour, whatever that hour is. Add them to get greater than or equal to what he needs. Questions on that? All right, go and clear your desk except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Graph paper would be a good idea for this quiz. However, you do not have to use graph paper for the quiz. Sheet of paper, pencil. Again, graph paper would be good, though not absolutely necessary. Quiz 27. Quiz 27. First last name at the top of your paper, along with today's date, which is 3/17/21. 3/17/21. So you just write St. Patrick's Day, or something like that. 3/17/21, today's date. Let's take a look at the quiz together very quickly. Numbers 1 through 3, graphing these inequalities. Numbers 4 through 9, solving these inequalities. Be sure to show your work on these. And then number 10, writing an inequality and then solving it to get the answer. All right, you may begin. Be sure to use the quiz copy as a cover sheet. more minutes to be finishing up. We will take a look at these tomorrow. For now, if you would, go ahead and turn in your textbooks back to page 152. Page 152. Have some graph paper out. And we want to work on what we started looking at yesterday. It's graphing linear inequalities. Graphing linear inequalities. For instance, something like 5x positive 3y is less than or equal to 9. Let's just throw out for an example. For a linear inequality, again, it looks just like a linear equation, except it doesn't have an equal sign. And so largely, we treat it like a linear equation, except for a little subtle differences. If this were a linear equation, we would either find intercepts or we get slope-intercept form. My recommendation is slope-intercept form. So let's go and get this to slope-intercept form. Reckon by first. Good, you get 3y is less than or equal to negative 5x, positive 9, and then of course, to get there we go. And again, if we were dividing by a negative, we would want to flip that inequality around. Doesn't really matter here since we didn't divide by the negative. And then comes the fun part. We graph just like we would have done previously. Go and set up a quick graph grid on your graph paper. Just as we had done previously, we would start by plotting our y-intercept. Then from there, we would rise and run according to whatever the slope indicated should be done. So again, no difference there at all. We'll start by plotting the y-intercept here at 3, and then from here, class, we would need to rise 5, run backward 3. So rise 5, backward 3. Now, it is possible that this may not fit on your graph grid if you didn't make it big enough. What if we couldn't rise 5 because there wasn't enough room, class? Then instead of going up 5, we could go down 5. But we'd have to remember to also reverse the direction of the run. So instead of running backward, we would now have to run forward. So we could also go down 5 and forward 3 to this spot. Either of those would work. Conventionally, rise over run, right? But there is that, technically, that option. Now, here's where things get different. If this were an equal sign, we just draw the line, we're done. But there's a couple of different things we have to do. First, we have to consider what kind of a line we would draw. Sometimes we draw a solid line, but other times, Noah, we draw a dotted or dashed line. How do we know? How do we know what to do? The or equal to. Little line right here tells me solid line. If there isn't an or equal to dashed line, but there is an or equal to, so using the straight edge, we will go ahead and draw a solid line. That's difference number one. But the biggest difference by far is that the line is really only a boundary here. It's really not the solution. It's a boundary between two halves of the Cartesian plane. That which is on the left and that which is on the right. And one of those two sides is actually the entire solution. So we're going to shade in everything on this side or everything on that side. How do we know what to shade, Maddie? You pick a test point in general. My recommendation is try this point right here, 0, 0. And let's just see, Brecken, if it works. Now, Brecken's already done the test. Brecken's over there shading. So Brecken already tested 0, 0. And my recommendation, go back to the original inequality, because if you forgot to flip a symbol like you were supposed to, you might end up shading the wrong sides. But if you go back to the original, should be able to get by. So 5 times 0, of course, class is 3 times 0 is, and 0 plus 0 is. So pretty much we get a statement that says 0 is less than or equal to 9. Is that true? Yeah. Which means this point works. Which means everything over here works. So we will, as Brecken was doing, shade in the left-hand side. Now, if 0, 0 didn't work, then that tells me shade the other side. Questions on this? Do we remember this from yesterday? Questions on this? Let's do one more together, and I'll have you work a couple on your own. Write this down. If you would, 4x negative y is less than 3. 4x negative y is less than 3. Walk me through. What do we need to do here, Maddie, if I want to graph this linear inequality? Okay, as a negative 4x. Okay, then what? I'm sorry? Divide away the negative 1 to get or just say 4x minus 3 might be an even easier way to say it. All right, good. So we've got it into the slope-intercept form. It wouldn't hurt to leave the over one so we can see the rise overrun here, but again, assuming we wouldn't make that mistake. Surely forgetting the run. A quick Cartesian plane here on your paper as well. And once again, like before, Brecken, to graph it, we'll start by plotting the at negative 3. Again, that is a y-intercept. Make sure you put it on the y-axis, right? And then from there, of course, Noah, we would forward 1 is a positive slope. All right, plenty of room to rise there, no issue. And when we draw the line, Maddie, back to you, dashed line this time. There is not an or equal to. So when we draw this line, we need to make a dashed line. But we're still not done, right? We have to shade one side or the other. Now, this line came dangerously close to the origin. And in a moment, we're going to look at some equations where the line goes through the origin. And if it does go through the origin, you can't use that as your test point. But the origin is here just barely to the left side of the line. Let's go back now and let's plug in 0, 0 to the original inequality. Now, Maddie handled it perfectly. So we could plug it in here and still get great results. But again, just in case, best course of action, always go back to the original. Does 0, 0 satisfy the inequality? Yes, it does. 0 minus 0, 0, which is less than 3. So once again, the origin works. So we'll go ahead and shade, once again, the entire left side of the graph. Had this been a greater than symbol, it wouldn't have worked. So we would have shaded the other side. Doesn't really matter. You shade whichever side the test point tells you to. Questions on this? All right, page 152. I want you to do numbers 1 through 7, the odd, there in the practice section. 1, 3, 5, 7. 4 Cartesian planes. Again, each Cartesian plane has to be its own thing. There's not really a way to put multiple of these on because fill up half the graph with shading. You don't have to make them particularly large, however. Let me show you numbers 1, 3, 5, and 7. They're on page 152. Once you finish the first one, go ahead and check your work. Good to go? Good to go? Maddie finishing the first one? Okay. That is fine. Good. As you finish 3, you can check your work. I went intercept method on 3. I just felt like it was too easy to plug in zeros here, but certainly could have gone slope intercept form. How'd we do? You didn't have your what? You drew solid. Your line was in a different spot? All right, let me double check and make sure I didn't make the mistake here. So if I'd gone slope intercept form, 2y is greater than negative x plus 4, divide everything by negative 2 to get y is less than positive a half x minus 2. So I should have had a y-intercept at negative 2, rise 1, run 2. Now this is the correct line. You figured it out? Yeah. Okay. Noah?
I had a negative 4 instead of those.
Did you do intercept method?
Yes.
Okay, so, yeah, so if you're doing the intercept method, you plug in a 0 here, that just makes the entire term drop out, and all we get is x is 4. So, yeah, all right. Bracket. Finished with 3? Moving on to 5, you two. Where is 3? Okay, so here was your 2, right? Negative 2. You need to rise 1, run over 2. So I'm not sure what that slope was there. Does that make sense? Okay. All right, for the sake of the video, let's go ahead and take a look at this very quickly here. I moved the 3x over as a negative. I divided everything by 5, came out really straightforward. Y-intercept 4, rise 3, run backward 5. Connect with a solid line because the or equal to. Try plugging in the zeros, and once again, 0, 0 doesn't work. So once again, I got to shade the other side. And then on number 7, I don't know that anyone got that far, but watch. If this were an equal sign, I just flip everything very easily. But as is, I wanted to go ahead and get the y by itself, so I completely flipped it. I put the negative y here. I kept the mouth open to the negative y. Then I put my 2x and then the positive 6. Then I just changed all the signs. So I got my y-intercept of -6, rise 2, run 1, connected with another solid line, but back up here, 6 minus 0 is less than or equal to 0. Well, again, it's a lie. So all 4 of these, it was a lie. So I shaded the other side of the line. Questions on this? All right, we'll practice with more of this in our next lesson. Do have 2 extra credit opportunities for you this evening. Page 153, word problems 31 and 32. So as we start this 4th quarter, opportunity to earn some extra credit on that next test. Page 153, word problems 31 and 32. All right, once you got that copy down, you are dismissed. Have a wonderful rest of your day.